Guys, as you can see, this is the DHT22 sensor, humidity and temperature, and this is a CHC40 USB TTL device. You can see the data is being sent, the blue LED is blinking. Let's go to the UART terminal and see what data is being received. Let me zoom in. So guys, as you can see, the data is being sent and the temperature is 29 degrees centigrade, humidity is 53%. That's how we are getting the data on the computer, and this processing is being done by the PIC. So this sensor sends the data to the PIC, and PIC processes the data and sends it to this computer or a laptop, whatever you have, over the serial protocol. You can see that humidity is 53%, temperature is 29 degrees centigrade. Hello guys, welcome to learning microcontrollers. In this video, I will show you how you can interface a DHT22 temperature and humidity sensor with a PIC16F877A microcontroller, and then we are going to send the output on a computer or a laptop using a USB to TTL device using UART port of a PIC microcontroller. So in this way, what I am going to do here is that I will be sending the output, that is the temperature and humidity value coming from the DHT22 sensor to a computer screen. Like we will be getting the data on our computer, and for that we will use an interface made using PIC16F877A microcontroller. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version, and this over here is the DHT22 humidity and temperature sensor, and this is the USB to TTL device. You can use any available USB to TTL device at your place, like FT232, CH340 or CP2012, something like that, or any other device. Whichever device you use must have the TX, RX and ground pin, and these pins are common in all the USB to TTL devices. Now let's first of all connect the DHT22 with a PIC. For that, as you can see, that DHT22 has 3 pins. Let me label them. The bottom one is the 5 volt, where there is a plus sign if you hold it like this. The center one is a signal where there is out written, and the top one is a ground, that is minus sign pin. Now guys, connect the ground pin directly with the ground of the PIC like this, ground pin of the PIC. And for the signal connected to any available digital input output pin of the PIC, I am going to use the pin number D0. And for the 5 volt pin connected to the VCC pin of the PIC. Maximum you can give is 5.5 volt. Now guys, for the CH340, let me label it. The top pin is a 5 volt, the next one is a VCC, then 3.3 volt, then TX, RX and ground. Now guys, here 5 volt VCC and 3.3 volt pins, we will not need to use them, because once we connect this device into the computer will auto power up the USB to TTL device. All we need is to connect the TX, RX and the ground pins. Now for the TX pin connected to the RX pin of the PIC like this, that is pin number 26, and for the RX pin of the USB to TTL device connected to the TX pin of the PIC, that is pin number 25 like this. Now guys, for the ground pin, just connected to the common ground of the PIC like this. In this way our connections are completed for both the devices. Now we will program this device, that is our PIC16F877A, in such a way that it will read the data from the DHT22 temperature and humidity sensor, and then it will process the data, and then it will send it to the USB to TTL device to display on the computer. And then we will use a USART or a serial monitor to see the data coming from the DHT22 sensor through PIC. So before we move to the programming, let me introduce you to the hardware. So guys, this over here is the hardware. As you can see, this is the DHT22 temperature and humidity sensor. This over here is a CHC40 USB to TTL device, and this on the right is the USB extension of the computer on which this CH340 is connected. And at the back you can see there it is the PIC16F877A microcontroller. There you can see that. So and behind it is the PIC3 programmer tool, which will be used to burn and power up the PIC. While this device will be auto powered from the computer. Like right now you can see that it is powered up from the computer. So guys, let's first of all get to the programming. So guys, this over here is our MikroC for PIC. Let me zoom in so you guys can see better. See, it's version 7.6.0. I have a video on that, how you can download and install the latest version of MikroC for PIC free of cost, full and final. So now what I am going to do is that I will go to my channel, and from my channel I will fetch the previous video I made on the DHT22. Let's go to the channel. There is a channel. Just go to my videos, and I will share the link to that video directly in the description, so you don't have to worry about it. Okay, there in my channel, in the videos, I have a video on DHT22 here, this one. We will take the programming from here and then we will simply modify it. That's what we are going to do here now. Now go to the description of this video. Here you have this Google Drive link to MikroC for PIC file. Just open it in the new tab like this. Go to that tab. Here you have the file. Just click on these three dots and click on download so we can have the file. Then we will simply modify it to make our new code. That video we interface this DHT22 with a LCD, and in this video we will use the same code, and instead of the LCD we will be sending the data to the computer. Now just open this file, the zip file. Here it is. Go to some suitable folder where you are going to paste it. I go to C and I write here codes, and here I paste it inside it. I extract the file here like this. Now here we have the MikroC for PIC files. Now I go to the MikroC, and on the MikroC you zoom in, click on file, click on open, go to the folder where you just extracted that file, and I extracted that in a folder called, okay, I had forgotten the folder, let me check again. Okay, it's C codes. The folder name is codes. So I forgot the name of the folder. I think I am getting older. Okay, write down C here. You will get the codes. Here we go. Open it, and here you have the MikroC for PIC file. And you all need is the .c file. C file. This is the C file. Double click. Okay, here we go. This is the code. Now this is the code from the previous video. Like this, you can see that it is having an LCD. We do not need an LCD, and we need to initialize the UART port so we can display the data on the UART port instead of sending this to the LCD. Now for that we will simply modify this code. Go to the file, first make a new file in which we will do the modification. Click on new project, write the name of the, this window pops up, new project with it, click on next, write the name of the project. I write DHT22 interface PIC16F877A to PC tutorial by learning microcontrollers. Simple as that. Now here the folder where your path or folder where your file will be saved. Now select the device. I am using the PIC16F877A, and the crystal I have is 20 MHz, so I select 20. Click on next and finish. Now guys, this window pops up. Before you do anything else, first of all, press Ctrl S to save your work like this. Now go to the other window which we just opened, downloaded and opened a file. You press Ctrl A, Ctrl C, copy the code and paste it here. Now go to the right and select the libraries we are going to use here. So we are using a conversion library because we cannot send data over the UART terminal in the integer or float form. We need to convert them to a string. For that, this library will be needed. And the other one is a UART library because now we are going to use a USB to TTL device, and the USB to TTL requires the UART pins. So, and for the UART pins, you need to initialize the library. Now here, first of all, we delete the LCD command because we are not going to need them. So these commands are for the LCD. I delete them like this, and I go down. In the void main, these are the command for the LCD clear cursor of LCD initialize. I delete them as well. And let me increase the delay. Okay, let it be 2, doesn't matter. Okay, now guys, we initialize the UART port here, UART1 INIT. Go to this And here in the example here, you have this command called UART init and set the baud rate. Now paste it in the void main, so the UART port gets initialized. Let me go up. Okay. In the void main, I write UART1 initialize. So the port is initialized. Now I give some initialization delay, not necessary to give, but I suggest to give it in the one-time loop. A 200 millisecond delay. And the baud rate is set to 9600. I have no problem with that, but after the baud rate you set here, remember when you are going to monitor the data, you have to set the same baud rate over there as well, as your data will not be received at all. Now guys, we have our UART port initialized and we have our LCD moved. Now we go down and there. Now instead of sending these LCD commands, we will send our UART commands. Now go to the right. Here you have this UART write text command. Double click on it. There you copy this command only, UART write text. Now we will be sending the text. Now first of all, we write here UART write text, and what we want to send, this is our temperature data, temperature 1. I paste it inside it. Now guys, what I do is that, and now we don't need this command anymore. Now to make it look presentable, I paste the same command again, and in the above command I write this. Okay, delete this. I accidentally wrote the same command. Okay, just UART write text above it and below it. So we should make it look presentable. So here the temperature, first it will send temperature equals to, and behind it I also give two spaces, so it will not coincide with the other data. And after that, once it send, it will send a C, means it's in Celsius like this. Then give two spaces for the next command, and just remove these commands. We no longer need the command. And the delay, I make it just 200, so the code should not be too fast that it will be difficult to read the data. And remove the LCD command because we no longer have the LCD library initialized. Now guys, this is for the temperature. Now do the same for the humidity. Now for the humidity, what I do is that I do the same. I copy this command, these three commands here as well, like this. And now instead of temperature, I write humidity. Oh, sorry, RH. RH is for the humidity. RH equal to, and then we will get the humidity data, and after that it will display a percentage sign instead of the C sign like this. Oh, sorry, why it went up? Okay, humidity, and here we got the percentage sign. Now delete these commands. We no longer are using the LCD library. Delete all the LCD related commands. Now make it 200 milliseconds. Now what is going to happen is that the same, we will get the temperature from the sensor as well in the previous video. You can watch that video, and once the temperature is here, then instead of sending it on the LCD, now we will write it over the UART terminal, UART port, and before that, to make it look presentable, we will send temperature equals to the temperature, and then we will send centigrade, and after that we will send the humidity. Similarly, we will write RH equals to, then the humidity, and then percentage. And now guys, these commands here, the checksum and other commands, I also replace them with these commands like this, as just replace the inner text like this with the. Now instead of displaying the data on the LCD, now they will send over the UART text channel, and they will be displayed on the UART terminal. USART terminal. Do the same here as well. Just copy this command, and instead of the LCD, whatever was written there, just copy the string and paste it here. Now it will be sent over the UART terminal, and remove the LCD command. Now guys, I build the code and see what happens. Okay, it's built successfully. Now let's open the PIC16 programmer tool. I have a video on this too. I will share the link to that video in the description. Select the microcontroller. PIC16F877A is the one I am using. Here we go. Click on file, import the hex file we just created. This is the file. Double click and click on write. Okay, the new file is being written. Let's wait for it to be written. Okay, the file is written. Please wait. Okay, the blue LED is not blinking. It means the data is not being sent. So let's power up the circuit using the PIC16 programmer tool. Click on. Okay, some data is being sent. Let's go to the USART terminal to see what is being received. So I zoom in. go to Tools, USART terminal here. Now my COM is 4. You can see whenever you initialize the port which COM, the dedicated COM for your USB TTL device is assigned. So you can check that in the device manager. Click on connect. Okay, here you go, we are receiving the data. You see, in the previous video I did this for the LCD, like I didn't divide it by 10 because LCD gets a stack overflow. But in this case, we can go back and divide it by 10. Like it is showing that temperature is 28.73. See, these are 3 digits. This means that it is 28.7. You have to divide it by 10. And the humidity is 52.4. Right? You can see that temperature is 28.7 and humidity is 52.4. Now see here the temperature is 26. See, temperature is 26 here. See, 26 degrees centigrade temperature at my place. So it is showing nearly fine because I am inside the room and AC is also on. See, now what I do is that I go back and I optimize the code. Because we are not using LCD, we can divide it by 10. So this is our temperature value, this one. Now I divided by 10 to bring it in proper digit form. Instead of getting the 3 digits, we will just get the required digits. Divide by 10. I don't want the decimal because this sensor is not that much accurate, so for the decimal to be of any use. Temperature equals to temperature divided by 10. Whatever the values will be divided by 10 and then it will be sent over the channel. Do the same for the humidity. This humidity equals to humidity divided by 10. Now whatever the humidity value is will be divided by 10 and then will be sent to the UART terminal. Build the code again. Okay, it's built. Let's build it again to make it sure. Okay, it's built. I click on the PIC16 programmer tool. Click on write. Okay, the file is being updated. New file is being burnt. Edited file. Let's see the hardware. Okay, nothing is being sent because the program is being written. Okay, it's written. Okay, something is being sent. Let's go to the USART terminal and see what is we are receiving here. Tools, USART terminal. Click on connect. Clear the previous screen. Now see, we are getting the 2-digit data. Temperature is 28. Humidity is 52%. That is something correct value. That is what we needed. You can see that the values we are getting, just monitor it for a second or two. Now what I do is that I use you can say a heat gun to change the temperature of the sensor. Let me show you. So let me bring in the heat gun. So you can see that this is a heat gun I am going to use. So let me apply it on the sensor, the heat. So this is enough. Let's place the heat gun back and go to the hardware. Let me zoom in so you guys can see better. See that the temperature has risen and humidity has fallen. That is what the heat do. Temperature is now 59 degrees centigrade, humidity has fallen to 15. See that because I gave heat and the heat I gave is too much. I set the heat gun to 480 degree. Now see the temperature is at 59 while the humidity is fallen. Now see again we have removed the heat gun and now they are coming back to normal. You can see that. Temperature is falling and humidity will start rising. Temperature is 57, humidity is 14% right now. Now see the sensor is coming back to normal temperature again. Again you will see that change, like it will try to come back to the normal state. So you can see that it is working like charm. See the humidity is rising. See it has started to rise and temperature has started to fall. 55 degrees centigrade, humidity 15, temperature 54. And humidity has gone 16 and it will rise up to like 50. That was initial real temperature, now 53, so it will keep on happening. So guys, this is it. If you have any questions, you can ask me in the comment. So thank you very much for your time guys, and have a nice day. We'll see you in the next video.